Well, hello friends. Today my topic is transformer, and here I have just tried to cover some of the basic concepts regarding the structure, why do we need a transformer, the constructional details, and some other basic concepts. Okay, so first of all, the question that comes in our mind is why do we need transformers, right? So here I am just showing you a diagram from where you can understand. See, this is the structure diagram related to the structure of the power system, right? So here you can see this is the power plant. This is your load center. So as we all know that the generating stations are located right some 100 kilometers or more than the load center. So actually what happens, the generator has some capacity. It can't generate the power at much higher level. Okay. So to generate that much of level, what we need is we have to step up that voltage with the help of what? The step up transformer. So what we do is we to transmit large power at this voltage level means what? Means you need much more quantity of current. So increased current means what? Again, increased losses, and which means that the efficiency of your transmission is becoming poor, right? And ultimately the cost involved is high. So in order to eliminate this problem, what we do is we just step up the generated voltage. Okay, we can step up to the limit up to 400 kilovolts, or it can be higher than this. Okay, then again what we do is we just we cannot just use this much amount of voltage in industries or at our homes. So what we do is we just step down this voltage with the help of a step down transformer, right? So based on this, we have some types of distributions also. It's the primary distribution, it's the secondary distribution. So just based on the voltage level. Okay. Here in this diagram, you can see it's the schematic diagram of the power system structure. So here you can see this is your transmission level. You can see the power is between 220 kilovolts to 400 kilovolts. Then is your sub transmission level between 33 kilovolts to 130 kilovolts, and then are your primary and the secondary level, which means the medium and the large consumers, which consume power really up to 440 volts to 230 volts accordingly we need. Then I'm just showing you the principle. As we all are familiar with the transformer, so the principle on which the transformer works is what? It's electromagnetic induction. And as we know, it's a static device. Remember, it's a static device, and that transfers electrical energy from one electrical circuit to the other electrical circuit through a medium of magnetic field. And the important thing is it does without a change in frequency. The frequency is always kept constant. Okay. So as we regarding the construction of a transformer, here you can see well, this is your what? The winding where the voltage is applied. This is your primary winding. Okay. And the winding where the load is connected is what? It's your secondary winding. Now, this is the magnetic core of a transformer. And it provides the path for the magnetic flux, you can see. Okay. So it is made up of what? A high grade silicon steel. Why? In order to minimize the losses. Okay. And here you can see the laminations are thin laminations. These are stacked up. Why? To minimize your eddy current losses. Okay. So this was the regarding the how the transformer structure is, regarding the core, the primary winding and the secondary winding, a basic idea about what a transformer is, right? Now based on the construction, we can say there, and then I've just shown in you the structure of the power system. Here you can see here I've shown you the step up and the step down transformer. So what is a step up transformer? Ultimately we can say that the where the secondary winding has more turn than the primary winding, then what will happen? The secondary voltage is higher than the primary voltage. Then this type of transformer is your step up transformer. And if this vice versa, the secondary voltage is lower than the primary voltage, then you will say it's a step down transformer. Okay. Now based on the construction, we can categorize the transformer as the core type transformer as well as the shell type transformer. Okay. So what is a core type transformer? Here you can see it's the construction of a core type transformer. So here the winding, this is the core, okay, and the winding is surrounding the core. So and the flux has what? Flux has a single path around the legs. These are the limbs. You can say it is called the limbs. This, okay. Here you can see that half of the low voltage winding is on one leg and the other half is on the second leg. And the low voltage winding is placed adjacent to the steel core and the high voltage winding is placed outside it in order to minimize the amount of insulation. Okay. And as I've told you, based on the application, it is based on it is used in the high voltage and high power application. Okay, then is your shell type transformer. So in shell type transformer, you can see it is also made up of E and F shaped laminations, which are actually stacked. Okay, stacked. I have told you to minimize the eddy current losses, and the windings you can say are placed at the center of the center leg in order to reduce leakage. Okay, in core type you have seen the windings were placed on the winding surrounds the considerable part of the core. It was in core type, and in shell type you can see what the windings are placed on the center leg in order to reduce leakage. Okay. And since here what is happening, the iron is surrounding entirely the core. This was about the shell type, and it is it is used for what? Low voltage applications. In low voltage applications. Now here I can give you an idea of how many types of transformers can be there. Okay. So in the power transmission, transformers are of two types: two winding, three winding, and auto transformers. Here you can see there are almost 16 types of transformers. It's the furnace transformers, rectifier, welding transformers, testing transformers, regulating, high voltage testing transformers, short circuit testing transformers, high frequency transformers, mining, current and voltage transformers, converter type, traction, communication, control and domestic transformers, then phase changing and distribution and earthing transformers. So these are the types of the how many types of transformers can be there. So from here you can see the widely used concept of transformers. They are such an useful in applications that we use it almost each and every area in our daily life. Okay. So okay friends, in the next lectures I'll be just continuing with the other topics like the what an ideal transformer is, what is a ideal transformer on no load, then ideal transformer on load, and the other topics also. Okay, so this was with this lecture. Thank you.